Here we're going to use WaveMason to simulate what happens when we take our 50 ohm transmission lines and run them into an infinite resistor. We're going to run it into an open. We're going to leave the end of the transmission line unterminated. So when I inject my Gaussian pulse, we're going to notice some interesting things. First, we notice that when we hit the open, our magnitude jumps up. The front part and the back part of this Gaussian pulse are actually summing with each other on that particular open plane. We notice that the wave that comes off is the same magnitude as we injected, and it's the same sign. It did not flip. And then from the return back into the source, we get all the energy back, 0 dB return. Now, when I inject my DC pulse, we see something a little interesting. This 1 volt jumps up to 2 volts at this. We're getting the reflection summing with the incident field, and then we end up with 2 volts eventually all through the line. So why did that happen? The source has been 2 volts all along, the actual voltage source, but I had a source impedance that was equal to that first transmission line. I have a 50 ohm source impedance going into a 50 ohm transmission line that acts like a voltage divider. So you're only getting half of the source voltage in that initial wave. The reflection off of the open sums with the incoming wave, and then you get the full source voltage seen along the transmission line.